The next talk will be a tandem talk from memetis and Bartels together, given by Christoph Wessendorf from memetis and from Florian Siemenroth from Bartels, both working together on microfluidics, on pumps and measurement of pumps. So I'm not sure who wants to start the presentation. I think, Christoph, it's your turn, right?
No, actually, it's my turn.
Okay. Florian, please.
Thomas. Never mind. Yeah, thank you. Very warm welcome, summer welcome from Christoph and me. As Thomas has already introduced us, we are from Bartels and memetis, manufacturing micropumps and microvalves. Just a quick explanation why we give that lecture mutually today is we both manufacture components that are quite complementary, so it's obvious to work together to find solutions together for microfluidic solutions together for the microfluidic society. And we want to give you a brief look on what we have been doing in the last few weeks or months that might give you a good impression of what can be done with active microfluidics. So the main question today that we would like to discuss within our presentation is what impact can a minituarizing active fluid control have, and what actually is necessary to realize such solutions in the field of point of care and pharmaceutical development. But before we go into microfluidic details, just a brief look at the current situation. The pandemic is not over yet. The good news is that we have low infection numbers, at least in Germany. 50% of the population have got their the first shot of the vaccination, and as I said before, summer is coming. That's great. The trouble is, autumn is coming as well afterwards. So, and we do not know anything about the immunity of those vaccines. And if there's one thing that we've learned in the pandemic is to be informed about the behavior in that pandemic situation might be quite reasonable. So what can we do to monitor the immunity status of the population quite reasonably and efficiently? And what can we do to decide in the end who really needs the third shot or the second shot for the re-vaccination, whose immunity status is really too low that is really necessary to be re-vaccinated. Our answer to that might be the point of care devices that are already on the market, but there is much space for more of those. We've got a best practice from GenSpeed Biotech from Austria. They've already developed a microfluidic liquid handling control system, liquid handling system in the end. It rather depends on the microfluidic chip that is implemented into that system and its biology on it. But in the end, it is a universal liquid handling system for point of care. It already detects MRSA, COVID-19 antigenes and antibodies. So this system would already be reasonable for monitoring the immunity status of the population, of the society. And those devices, those reusable, non-disposable devices that can be run by disposable parts like microfluidic chips with a certain biology on it, can be set up and installed everywhere around the society, like everything that can be imagined as general practitioners, pharmacies, lobbies of hotels, restaurants, maybe even, or bigger events. But how can we actually realize such solutions, and why aren't there any more systems like those of GenSpeed? So maybe Christoph has got an answer to that question.
Yeah, I might not have the answer, but that's something we want to dig a little deeper, which we want to discuss today. And I guess when we look at yeah, at the question that Florian just raised, we see that over the last 20 years, there were different failure modes of microfluidics identified, or potential failure modes for industrialization identified. On one hand, I guess the technology was considered not easily accessible, and therefore maybe the choice went more into the direction of conventional active fluidics, so what was easily available. On the other hand, maybe the technology, so again, speaking of active microfluidic control or fluidic control, was not considered scalable, or maybe products not robust enough or fully available. And I guess at least one of the big points was or is that know-how was not available. But we asked ourselves the question if this is actually the case today. And I mean, we cannot answer all these questions, but we want to dig a little deeper on the second point, so the scalability and availability of microfluidic products. And today, when we talk about microfluidics, and I guess we also did so in previous talks, we often refer to a microfluidic chip, basically the core of a microfluidic analysis, but of course also the devices around that. Nevertheless, the core of the analysis, the chip, is really in the focus of our interest. And the fluidic periphery, which is around that, which for illustration reasons, I put here on a picture on that slide, is still in general relatively large. It might be bulky even. It has relatively large volumes of reagents or samples inside often. It might also be relatively expensive, so meaning capital expenditure is large, and high energy or reagent consumption for these fluidic periphery might be large. And looking at basically this contrast of the microfluidic periphery, which I just characterized a little deeper, and the main benefits of microfluidics, which is low operational cost, small volume, small channels, or resource saving operation, we see that actually not all of these benefits really reach the point of care or reach the end user in the end. We cannot really leverage these advantages of microfluidics. And this is a situation which Florian and I, or Bartels and memetis, we said we want to see if or how a system or how components should actually look like, how the fluidic periphery should look like on actually bringing these advantages of microfluidics to the end user. And here we said it's should be relatively easy from a theoretical point of view. We would need active components that enable automation, that somehow I would say are low in weight and small in size. And as we heard before also from the colleague of Fluigent, they should be able to be battery powered, so they would need a low energy consumption level in order to basically create a fluidic system that can really leverage the advantages of microfluidics. And I guess we would all agree that this would be pretty neat, but we asked the question then, what is actually holding us back? And if in essence, we figured out that all of these components to realize an active fluidic control system or active microfluidic control system are already available. So there are micro pumps based on piezo technology. There are ultra compact valves with different kind of actuation technology. In our case, shape memory alloy actuation. There are fluidic chips that are already produced in the thousands or large numbers. So there's a lot of experience here, and there are also pressure and flow sensors in coin size, I would say. And all these components are actually ready to be used and to leverage the outlined benefits of an active system to be used at the point of care. And this is not just a theoretical availability. And I guess the fact that Florian and I are here today to present Bartels and memetis products also together, and listing here also products from Microfluidic Chip Shop and Sensirion, you're also participating, shows that this is actually going well beyond products being available. So, but maybe the current challenge in this case is to actually combine these components and not just the general availability. And for this, we can say not really, because we can happily demonstrate that all of these outlined components are not only available, but they are also ready to be integrated into a customer-specific system. And to demonstrate this, we took components from 4 companies, all present here today. And we see that with these off-the-shelf components, we were able to realize a system in the overall size of 96 well plate that has, for example, a handling frame of the Microfluidic Chip Shop, the chips from Microfluidic Chip Shop, flow sensors, the SLF3 used from Sensirion, or the Bartels Micropump MP6. We used single tanks from the Microfluidic Chip Shop, bistable valves, normally closed valves from memetis, and also a smart controller for everything, and built basically a fully functional, relatively powerful fluidic system, I would say, in a very small installation place. But now the big question is actually, what can we do with this fluidic system? And what is basically the thing that we are enabling with such a fluidic system?
Correct. Especially to show you or to prove that this system already really works, and it's not just let's say photoshopped or so, as in the picture that Christoph has shown. This developed system really does what it should do. We have a flow controller consisting of our micropump, the MP6, and a thermal flow sensor from Sensirion that is able to dose from the single tanks from Chip Shop into a microfluidic chip from Chip Shop with a certain flow rate that can already been controlled via a user interface, via Bluetooth. So that flow control that you see in that handling frame from Chip Shop is already accessible via Bluetooth with a user interface. We have the two-way valves from memetis addressing several reservoirs, and there was even the possibility that memetis has developed logic combination of 4 two-way valves to enable our micropump, which is unidirectional, to have a flow reversal, which is shown in the right bottom corner. Just to give you an impression on our workflow, we simply sketched that idea within an online meeting within 15 minutes or so. Then the 4 companies or the 3 companies would have sent the parts to our lab, and we plugged this system together within, let's say, half an hour. So to give you an impression of time, combining those microfluidic components can be very fast as they are really available and functioning. So this was quite easy actually, and the size benefit is obvious, as it is in the size range of a 96 well plate format or less than a DIN A4 sheet. So and still adaptable and customizable. So you can plug those components together as you want and realize whatever you want. So that can have a high impact, a big impact. Let's have a look at the strongest benefits. We can set up systems that are smart and active, so we can have a fully automated process that can be controlled wireless and whatever, and can already and only consumes a small amount of power, as all the components can be powered by a battery. The fact that we are utilizing microfluidic components leads to the circumstances that we only have a small amount of liquid that is necessary. So we can really save reagents, and we can implement all the components on a very small footprint. In addition, we are already in a quite low cost range. So the system that you have seen on the picture, on the videos, would only cost a few €100 if you buy only one component of these. So, and it can have a much lower price if you increase volume for several devices, for several products, or a bigger amount of products. A quick advertise slide for our specific components. Our micropump MP6 has got a wide range of fluidic performance. It can promote liquids and gases. It has small dimensions. There's only one material in contact with fluid, and we already have a high volume production in-house. So these components are really available and accessible.
Yes, and in case our video inspired you and you're planning about setting up an own fluidic control system, I would also be happy if you consider at least also the memetis valves. Therefore, I will also briefly shoot that out there. We have, what you just saw in the video was the Series 09 valve, which is, I would say, the size of probably half a sugar cube, weighs less than 1 gram, has a very low power consumption with below 0.3 watt, and is powered with below 5 volt. The internal volume is also very low in order to save reagents. So in our opinion, a valve very well suitable for a portable device or operation at the point of care. And yeah, finally, it was a pleasure for us to present our products here. We are now available, of course, for questions. And by the way, we both have, so not Florian and myself, but Bartels and memetis, very great LinkedIn presences. So if you want to stay up to date or get more information on what we are doing, follow us on LinkedIn. There's always something to explore, and just in order to make sure you stay up to date. Thanks a lot.
Thank you.
Thank you very much, Florian, Christoph. A very interesting talk, and I'm personally, I like very much this idea of working together with different companies and putting in such an easy way these components together to a working system. But there are two critical questions on exactly this. One is, of course, coming from Henne, who likes to standardize interfaces, and he asks if there are activities ongoing to integrate the components you mentioned more efficiently. And the same direction is a remark from, or a question from Victor Vier. The system you show costs probably several €100 and needs to be cleaned after use. Is it really a solution for point of care?
Sure.
Two good questions. Yeah, so maybe starting with the first one from Henne. So, I mean, I'm speaking of memetis now, and I think Florian can provide the Bartels perspective. So we are trying, or in every customer project we have, we are trying to figure out, I wouldn't call it a standard, but a configuration which allows the most users actually to use our valves. And interestingly, we do not have a lot of requests there when it comes to the fluidics standardization. Maybe it's more from an electrical control perspective. So that means step by step, we are learning from our customer projects. We are trying to implement their feedback, but we ourselves, we do not drive standardization actively, even though I would very much be happy if we could stick to a standard and implement that.
Then we work with Henne.
maybe one add-on for that. Christoph and I were just in a discussion right before that the conference, and of course we are always evaluating what can be next steps. So there might be some ideas in combining technologies really in a complete setup. It always depends on the need of markets and the let's say the microfluidic society. But I think we are both quite open to integrate everything, our technology, into everything that comes on our desk actually. So let's see what the future brings. To answer the other question regarding contamination of the fluidic system, that's true, of course, that the micropump is, for example, the liquid flow sensor is contamined if we dose directly. In case of the GenSpeed system, for example, there are already micropumps inside. The three agents that are dosed from the tanks in this fluidic systems are standard liquids, and they would always be the same, and they simply the micropump simply dose those three reagents on a fluidic chip, and the fluidic chip is in the end the disposable one. So the GenSpeed system is reusable, and the three reagents can be exchanged after the tanks are empty, and only the chip which has got the biology on it, that would be the disposable one. In addition, our micropump is able to promote gases as well. So we even can realize, so this is just an example, we can even realize a non-contamined micropump system or microfluidic system. So there are many opportunities and many chances. So let's have those discussions. That is what Christoph and I love.
And we will definitely continue that. So thank you again to the both of you. And we come to the next presentation.